So what we're going to do now is we're going to take a data set that different students have uh, recorded on pine needle length. So I asked students to record up to 21 uh, trees, and for each tree I asked them to record the needle length of at least one group of needles. And so here we're looking at data for 17 different students. Most of them got their 21, but not all of them. And so what we're going to do is create a frequency histogram out of all of these numbers. The first step that I will do is figure out the minimum value and the maximum value from this table. And while you can do that visually, there is an equation in Excel that you can use. So here I am showing you that equation. So for the maximum value, it's just simply max, and then you select the data that you want to get that maximum value from. The minimum value is the MIN, and then you select the area that you want to get that data from. After you get the maximum and minimum value, then you just subtract the two, the maximum minus the minimum, and that will give you the range over which you want to create your frequency histogram. I will then divide that value by the number of bars or bins that I want to create, and that generally varies based on the number of values that you're looking at. I typically draw mine somewhere between 5 to 10, but if you have a lot of data, you might even go up to 20 or 50 different bins. Here, I've decided to use just 10 bins, which will correspond to 10 bars in my frequency histogram. I've given the bins here, and so how to do that is I need to have my smallest value, my minimum, in my smallest bin or range there, and I want my maximum value in my greatest bin. And I know that each bin or group should be around 20 different values. So 50 to 70. If I start with the 50 range, then I'll go up to the 70 for that bin, then 70 to 90, and so on. So each bin corresponds to around 20 for that range. Then I go back to the data table and I count the number of observations that fall within that bin. So the 50 to 70, you look through, and here, for example, is one that's 57.5. So there's one, and as you look through, you're between 50 and 70. And another way that you could do this is do a find if you know that exact value. Or, as I've done, I've created an equation to count the numbers in each bin. So I'll show that to you. It's a little more complicated. Basically, I'm going to count if my data is less than or greater than 50 here, and then I'm going to subtract anything that is over 70. And that gives me just two values, two observations that are between 50 to 70. I've done that for each bin to count the numbers, the observations that fit within that range. And now we're going to create a frequency diagram. Okay, so what we're going to do then is determine our axes. And so we'll have a y-axis and an x-axis. The x-axis is our independent variable here, and that is going to be our bins that we created of pine needle length. and I had students measure in millimeters, so there's my units. And then my Y will be the frequency. And so for a frequency histogram, that should typically be what your Y is some sort of count or frequency. Then I'll need the bends. So I had a 50 to 70 bend, a 70.1 to 90, and I'm going to fill that in. Okay, so now that I've got the x-axis filled out for each bend, for the smallest with the values 50 to 70, and for the largest values between 250 and 270. So for our 50 to 70 range, we had a count of 2, and for the most values, we had a count of 73. So our Y has to go from 0, and I'll put up 75 here for our maximum. And then you want to make sure that you have equal values for each tick mark. So maybe these go by 10, 10, 20, 30, 40, 50, 60, 70, and so this last one here would be 80 rather than 75, but that's pretty close. Now we draw in our bars. We have 2 for that first bar. It's going to be way down here. 70.1 to 90, we had 9, so it's going to be almost to the 10. 90.1 to 110 is 37. It's going to go up. 110 to 130, we had 70. Up. 130 to 150, we had 73, so a teeny bit higher there. 150 to 170, 59. 170 to 190, 27. 190 to 210, 34. 210 to 230, 18. And so I'm just drawing that bar high enough to reach that particular frequency. 230 to 259, 250 to 273. And so we've created our frequency distribution. What we're going to go through in just a moment is what would happen if I had a whole lot of bends. And so rather than seeing them as bars, you'll actually be able to see this frequency as a curve. But it represents the same type of information, account for the number of particular observations.